grade.
Okay, so we left off, I believe, we were on slide 47, yeah.
We're gonna watch the video of ice core sampling. You said we're gonna
Today.
Okay.
Today, yeah, I've said that multiple times, you just have to listen.
That's
Just
not fun.
listen. So slide 47, I know we were rushing. So yesterday, we finished relative dating, that comparison, and then absolute dating. What you need to realize is that it is more specific, it is more scientific, it gives you an estimate, not just a range, basically. It actually, says, hey, it's probably like, 50,000 years old, or 100,000 years old, or whatever. Those are our two types of dating. Absolute dating is also called radiometric dating, which is the process of using the radioactive decay. So a couple of videos that we're going to watch today will show and explain a little bit about that process. Understand that's really as far this year as you need to understand, is that absolute dating is using radioactive decay and using that process to basically figure out what exactly, or what the age is of the item. Right. Then we started talking about ice core sampling as another way of understanding what is going on, or what has gone on in our past. All right, and so with ice core sampling, you're analyzing the chemical and physical properties of things that were in our atmosphere in the past. So it's almost like this ice is formed like sedimentary rock, right? Snowflakes get deposited, then more get deposited, and then more and more and more and more, and you have all that pressure pushing down, and it compacts it into this big ice cap, the polar ice cap. And so then they drill down in and they pull out this cylinder, this chunk, which they call an ice core. And then from that, you'll see in these videos, they're going to actually slice it almost like deli meat, and they're going to be able to look at variations, look at a lot of different things that are going to be able to tell us the past temperature, atmospheric circulation, precipitation, ocean volumes, atmospheric dust. If there were any volcanic eruptions, some of that ash will be floating around and would have gotten trapped with the ice and the snowflakes. Solar variability, like the strength of the sun, actually. What might be blocking some of the strength, and then actual marine biological productivity. So what's going on with the life in our oceans even. So a lot of really kind of random things that you would think would have no, like, how are they even getting that? They're able, they run a lot of very specific tests on these ice cores, and they're able to interpret it and get a lot of this information, which is pretty phenomenal, just from looking at a slice of ice, basically. And even if there have been forest fires. So again, you learned last year in 7th grade that about the trade winds and wind patterns and currents and things like that. So we know that the air that is here is not going to stay here, right? It's going to blow all around. So if something happens here, it could get detected hundreds or even thousands of miles away. And if that air gets taken over to, up north where, it could get very, very cold, it could be in our Arctic areas, well, then it could join up with some of the snowflakes, and those then get, maybe in a couple thousand years, they will be part of the ice core sample that would get analyzed later. So kind of interesting how this all can happen. And so kind of to wrap everything up, we have the rock record, we have our fossil record, we can use the ice core samples, and we know that even with all that information, our information is incomplete. Like, we know that there are gaps. We know we don't have the whole story. So if we said that, Earth's living history is like our big book, there's going to be chapters and pages and sections that are missing. And so over time, maybe we'll find more information and be able to kind of fill in that book of our history. But we do have a lot of information. It's definitely not just empty. But we're able to analyze the fossils from the fossil index, And so we can definitely see that there is a pattern of evolution and adaptation that has taken place over our history. And we know that this process is not done, right? This is something that's going to continue. We have not reached the end by any means. So new information is getting gathered daily, weekly. You know, it's happening all around us all the time. And our processes will get better. We'll get more, you know, better technologies that are going to be able to help scientists collect more information and analyze more things that maybe in the past they couldn't. Okay, so this is a evolving and adapting type of process. Okay, and that is where we will stop in our notes.
Because they're done.